Today you will be learning lesson 3.2 on solving inequalities using addition and subtraction. One of the vocabulary words we need for this lesson is equivalent inequalities. And if you remember, equivalent equations were equations that have the same solution. This is the same thing, but now we're talking about inequalities. So equivalent inequalities are inequalities that have the same solution. And you guys actually wrote some of these yesterday in your notes, but let's review them again. Okay, so it says write an inequality that is equivalent to the given inequality. So if I have b is greater than negative 10, and if I reverse that negative 10 and that b, I switch them around, I also need to switch my sign. So if b is greater than negative 10, then negative 10 is less than b. Notice it's pointing towards the negative 10. Here it's still pointed towards the negative 10. Right? So since negative 7 is less than negative 1, I can reverse that and say negative 1 is greater than negative 7. Right? Same type of statement. If I reverse around the numbers, I have to reverse around my symbol in order for those inequalities to still be equivalent. Okay? So the next one, since 10 is greater than or equal to negative 3, it's pointing towards that negative 3. Over here, it was greater than or equal to, it needs to become less than or equal to. So since 10 is greater than or equal to negative 3, I can also say that negative 3 is less than or equal to 10. And the last one says h is less than or equal to 0. If I reverse that around, 0 is then greater than or equal to h. Okay? Equivalent inequalities. Inequalities that have the same solution. So up here it says cross out the inequalities that are not equivalent to x is less than or equal to 3. Okay? If I look at this one, here it's pointing towards the x, here it's pointing towards the x, here they reversed it, so this one does work. Okay? 3 is also greater than or equal to x. Okay? X is less than or equal to 1/3. 1/3 is not the same as 3, so that is not the same answers. Okay, here we have an inequality like what we're trying to solve today, and we'll learn about these. If x plus 2 is greater than or equal to 5, okay, well if I solve this, and we solve this using our properties of equality, meaning I have to get rid of 2 on both sides, I end up with x is greater than or equal to 3. Okay? Since the symbol is greater than or equal to, here it's less than or equal to, this one will not work. Okay? The next one, x plus 2 is less than or equal to 5 minus 2. Well, the first thing I can do over here is combine my like terms. So I have x plus 2. X plus 2 is less than or equal to 3. Okay? So when I subtract that 2, and I subtract that 2 over here, I end up with x is less than or equal to 1, which again is not the same because my answer is not the same. So this one is not an equivalent inequality either. So the only one that was equivalent was this x, or 3 is greater than or equal to x. When we are solving inequalities with addition or subtraction, we just use our properties of equality, so whatever you do on one side, you do to the other. Okay, we have to show that they are still equal. Okay, so our key concept today. When you add or subtract the same number on each side of an inequality, the relationship between the two sides does not change, meaning those two sides stay equal. Right? Whatever you do to one side, you have to do to the other. Okay? It says on each side. Okay? So complete the inequality using either the addition property of equality or the subtraction property of inequality. Okay? So since 3 is greater than negative 1, then 3 plus 5, so over here the change is they added 5, is still going to be greater than negative 1 plus 5. I have to keep that change the same in order for those inequalities to remain equivalent. Okay? So 4 is less than or equal to 9 and if I add n to that 4, I also need to add n to that 9, the same side, to make them remain equivalent. This is your addition property of inequality, because we are adding on both sides. Okay? So if z is less than 8, then z minus -4 is less than 8 minus, again, the exact same thing we changed on the other side, a -4. Okay? This was our change. This is our new change. Okay? Those two sides have to be exactly the same. So if I have w is greater than or equal to k, then w minus t, so our change is minus t. If we wanted to stay equal, I also need to minus t on that other side of my inequality symbol. Okay, so the first two are the addition property of inequality. The second two are the subtraction property of inequality, because we're subtracting on both sides of that inequality symbol. All right, so let's solve some. Solve each inequality and graph the solution. Okay, just like we did for equations, I'm going to draw a line down from this symbol. Okay, so I have t plus 9 is less than -4. My goal is to get t by itself. Have to get rid of plus 9, so I minus side 9, and whatever I do on one side, I do to the other. These two cancel, and I have t. My symbol is going to stay the same, so it's less than, and -4 minus 9, they're both negative, so I add them, -13. I'm just going to write it down here so it's a little clearer. T is less than -13. Okay, so my solution is all real numbers less than -13. So they want me to graph the solution. If you remember from yesterday, we have an option to graph using an open circle or a closed circle. Okay, in this case, our symbol is just less than, so we don't want the closed. We're going to use that open symbol. So I'm going to number my number line, and I'm just going to number a couple of them. So this one's -13. This one I'm going to make -12. This one here we're going to make -10. Oops, -11 is what that should have been. Okay. Back here we're going to go -14. Over here, -15. Okay, so what I need to do to graph my solution is we decided an open circle because it's not or equal to. So I'm going to put an open circle on my -13, and less than, my values that are smaller than -13 are to the left. So I'm going to shade in that left side of the number line. Okay, now make sure when you are shading yours, I can tell exactly where your shaded part is. Make it nice and dark so I can tell your arrow is going to the left or to the right, and your arrow sticks out compared to the number line. Okay. The next one, the inequality, the y is on the other side. That still doesn't change my steps at all. My goal is still to get y by itself. Okay. So in order to do that, I need to get rid of a plus 12. So I'm -12. Whatever I do on one side, I again do to the other. Okay, in here I end up with y, my symbol, because these two cancel. Okay, my symbol comes straight down, so greater than or equal to is my symbol, -13 again, because they're both negative, so we add them. And if you remember yesterday, sometimes it's always easiest to put that variable first. Again, not a requirement, but I like to do mine that way, so I'm going to start with y, and then my symbol becomes less than or equal to, it's pointing towards my y, so I need to change that symbol, less than or equal to -13. So y is all values less than or equal to -13. So this time I'm going to use that closed circle, so I'm going to put -13 in the middle. For here I'm going to put -12. Here -11. And you always should number your number lines. Okay, my pen froze again, so I'll have to wait a second here. Uh-oh. Clear that. It'll let me. to erase it. Sorry about that. Okay, so hopefully you can still tell what we had for an answer there. Okay, here's negative 13, here's negative 14, here is negative 15. Okay, so since it's or equal to down here, okay, my circle around that negative 13 gets shaded in because it can be negative 13. Okay, and this is again saying less than, so my values less than negative 13 are to the left. Okay, and remember that if you like less than and left, that only works if your variable is written first. Okay, and I'm again going to make sure I can tell I'm going over here to the left and shading that in nice and dark. Right? So these were both problems using the subtraction property of equality to isolate that variable. Let's do some addition property of equality. Okay? I have n minus 5 is less than negative 3. Okay? So my goal is to get n all by itself. Here's my inequality symbol. To get rid of minus 5, I use that addition property equality and I add 5 to each side. Leave me with n, because the 5's cancel. Symbol just comes straight down. It's less than, and here negative 3 plus 5 gives me a positive 2. So n is less than 2. So on my number line, I'm going to put 2 in the middle. Make 3. Here's 4. Before 2, I have 1 and 0. Okay, since my symbol is less than, I just need an open circle. Okay, it stays open. And less than, my numbers less than 2 are to the left. Okay, again, shading that number line in nice and dark. Okay, open circle because it's not or equal to. Okay. The last one again has that variable on the other side, or the next one I should say. My goal is to get m by itself. So I need to get rid of minus 11. So I add 11, and whatever I do to one side, I do to the other. Okay, the 11's cancel on the right. So I have m, my symbol, less than or equal to. Negative 2 plus 11. The 11 is bigger, so my answer is going to be a positive 9. Okay. Okay, you can leave your answer like that if you want to. Just make sure you know how to graph those answers. Okay. Or if you want to rewrite it, some of you might find that easier. So m is less than or equal to 9. And I gave you all less than problems, but if it was greater than, you'd move to the right. So in the middle of my number line, I'm going to put a 9. Here we're going to put a 10. Here we're going to put 11. Before 9, we have 8 and 7. Okay, this is an or equal to graph now. So on that 9, I need a solid circle. And the numbers that are less than 9 are to the left. Shading that in nice and dark so you can tell where your solution is. Okay. The addition property of equality.